Hello, my fellow YouTubers. This is Roy back again. I made some modifications to my Tesla coil, and let's go over it. All right. What do we have here? Alrighty. So I added a second coil and wound it with 26 gauge. Comes to the top load. Tuned the primary to it. Haven't changed the capacitance. Still at 7 nanofarads, 7 bottles. And this is experiment here that I want to talk to you guys about was the diameter of this lower coil is 4 1/4, and the diameter of this tubing here is 2 1/4. So there's a 2-inch difference in radius, and also there's a step down in the diameter of this wires. 26 gauge, yeah, but it's 26. This is like 22 gauge, 24 maybe. So there's a step down in there. So the experiment I wanted to do is go to Tesla's old patent in I believe it was patent from Colorado Springs experiments, but to Wardenclyffe, and it was his tower, and he uses a secondary conductor, which he calls B prime. He shows a primary coil, then he shows as C, and then he shows an A coil, and then he shows a B coil, and then he shows a B prime coil. So we're going to treat this as B and B prime off of C without A. Here we go there. So I made a video yesterday and great results on the video on the adjustments I made. And this one, I would say is 30% more efficient and 30% more energy coming out of all of this. This is extreme, I'm going to call it. I guess what we did here was we built up our field, and then we increased pressure, and then we have a release of the pressure. And I'm gonna just cut the chase, get right to it, fire it up. In the beginning, I'm not gonna fire up the fan. I'm gonna leave the gap real tight, and we're just gonna mess around and see the radiance of this light bulb here and that bulb of where it transversed out to. And not on this video, but we're going to take this matching coil, the sister coil, to that one. Same turn, same amount of wire, and then we're going to hook that up to an air capacitor and to LED. And when we fire this up, we're going to go out walking around and light up the LED. And I'll show you guys how we do that, what we use, what kind of diodes we use, and the whole process. So let's go ahead and guess we're going to turn off some lights. Guess we can show a light out. Shut the garage door a little bit. Alrighty. Turn the light out. We're just going to go right there. Low spark gap, nothing going on. Light bulb lit up. Now, there's no breakout or anything happening. And we got the light lighting up. So there goes my wireless. Very small gap. Lights lighting up, really good. Good radius coming out from it too. I mean, I'm pretty good distance. Of course, I had to touch that one to complete the circuit. Let's go ahead and fire up the fan. Breaker, breaker, 19. That's a breakout there. So I think what happened is the bottom of the secondary is grounded out. Let's take a look here. Yeah, there's the bottom of the secondary. Let's scooch that out just a little bit further from the primary. And that happens sometimes when I have the spark gap too far apart. Let's move it a little closer and check out the response on the top. NASCAR! Holy cannoli. What the hell, guys? I can't even open this thing wide open. I was too afraid. I'm too close to it. You're about smacking me in the forehead almost. I would sizzle my phone. So,